to start with our speaker, currently he told me he is homeless. He used to live in Washington State in the rainforest. Right now he doesn't have a home except for a hotel room for 1 month. And after that he will move to a desert. So to him it's a time of radical change, yes, which he will talk about as well in his talk. He has been contributing for 3.5 years to the Nix packages. It was his major project was rewriting the GCC bootstrap. His day job, although, is microchip designer for Western Semiconductor. Anything else you would like to add?
No.
All right. Then I'll have you a lot of fun, wish you a lot of fun with our next talker. Please welcome.
Thank you. So my name is up here on the slide, below the title. That's pronounced verbally Adam Joseph, but my PGP key is the name that I tend to use. So, the title of the talk today, as you've probably seen, is sixos, a Nix OS without systemd. And I'd like to point out two things that you can, or something that you can infer just by looking at the title. You can tell that I'm a Haskell fan from the title of this talk because of two things. The first of these is the fact that the talk's title is white space sensitive. So, of course, Nix OS is not quite the same thing as Nix OS. And the other reason you can tell that I'm a Haskell fan is that it's also a case-sensitive title. So, I'd like to start out by reviewing some ancient history. A lot of you probably already know this. Back in the olden days, there was really only one option for process one on a Linux system. You had a non-supervising process one like systemd init, which would not really monitor the state of a process, whether or not it kept running or not. So if you ran Debian a long time ago, you probably remember you could start a service, and if it died for some reason, the PID1 supervisor would not restart it. It was up to you to monitor whether a process had failed or come back up. Those were the bad old days. Then we came into the era of process supervisors. And like so many other good things in the free software world, it began with DJB. In the beginning, DJB said, let there be daemon tools, which was effectively the first process supervising PID1. And daemon tools begat Jarrett Pape's Runit, which is still in use today, by the way, by a major Linux distribution. Void Linux still uses Runit as its process supervisor. It's an outstanding piece of software. And Runit has sort of reached terminal feature set. It is complete, it is debugged, it works, it doesn't aspire to new features. And so Lauren Burkott's S6 supervisor can be seen as the next generation of process supervisors. It's open to adding new features, has added many, and it's a really incredibly well-written code base. So that's kind of the background history of process supervision in PID1. So I'd like to tell you how my personal history interweaves with all of this. Once upon a time, I was a happy Debian user. I used Runit as my process supervisor because at the time Debian was agnostic to which process supervisor you chose. And it was even part of the Debian policy manual that if you designed a package for Debian, they expected it to work with multiple different choices of PID1. So I was very happy with that. I liked Runit. Then systemd appeared on the scene. I took a look at it and I said, okay, this is a neat option, but it's not really for me, so I think I'll stick with Runit. And there were no problems. I was still happy. And then there was the bad day when Debian decided to terminate support for any other option of process supervisor except for systemd. And that was the day I went from being happy to no longer being happy. So at that point, I simply stuck with the version of Debian that had support for multiple process supervisor options. That, at the time, was Debian stable, and then it became Debian old stable, and then it became old stable, and then I had a really, really big problem. So for a period of several years, I was running a grievously out-of-date version of Debian, and that made me very unhappy. So, I'd like to digress a little bit and talk about why it's a problem to have only one choice of PID1. Because I've had this discussion with systemd advocates sometimes, and they say, well, it's Linux. You only have one choice of kernel. Why is it such a problem that you only have one choice of PID1? Isn't it just the same thing as the kernel? And I'd like to respond to this because I don't think I've ever really seen a clear and coherent comeback to this point from the PID1 monoculture advocacy. I'd like to point out that the Linux kernel's interface to userspace, the syscall interface, is an incredibly simple interface. You can give undergraduate college students the assignment to write an emulator for this interface. You know, for example, if you're transpiling MIPS machine code into Java JVM bytecode, you have to emulate this syscall user interface. It is shockingly easy to emulate it because it's a very, very small, very well-defined, and very stable interface. We used to have our undergraduates do this in a single semester. So like I said, it's a simple interface, and it's also incredibly stable. You've probably heard the famous quote from Linus, "We don't break user space." And sort of the analogous comment from the systemd people is, we've never heard of this thing called semantic versioning. So I would argue that there is no analogy between you only have one kernel, so it's okay to only have one process supervisor, because the API surface of the process supervisor is enormous and constantly changing, and there's no commitment to stability there like there is for the kernel syscall interface. So I think that's the key difference. That's why I think it's okay to have only one kernel for Linux, and it's not okay to have only one process supervisor, because if you want to replace the kernel, the amount of stuff you have to re-implement is actually, the API surface is very small and controlled. And this ties into the theme for this track at C3 that this talk is part of, dealing with centralization. And I think this is as close as I'm going to get to philosophy in this talk. But I'd like to point out that anytime you have only one option, and that option exposes a highly complex, highly unstable interface, it puts you, the user, at the mercy of whoever controls the development agenda for that thing that you only have one choice of, that thing that has a complex and unstable user interface. They can constantly keep you playing catch up with them. If you're an old fart like me, you probably remember the Windows Win32 API. For a long time, the Linux world tried to play catch up with that, and tried to emulate the Windows API. And Wine works shockingly well for what it does, but it's an enormous API, and Wine is never actually going to catch up to Windows. It's never going to reach feature parity. This is the reason why most of the Linux world never took it as a goal to run Windows binaries. We knew we would never be able to catch up with them. We knew they would always remain in control of the development agenda. I'd also like to point out that this principle applies not only to software, but also to network protocols. This is why, if you look at planet Earth's network stack, the one layer of the network stack that we all must agree on, the IP layer, is also the simplest and most stable of all the layers. All the layers above it are much more complex and change much more frequently, as well as all the layers below it. But that's okay, because we don't have to agree on them. I can use Ethernet, you can use Token Ring. I can use TCP, you can use QUIC. But the IP layer is the layer that we all have to agree on to be part of a single planet Earth internet. And that's the same reason why the IP layer has to be the simplest and most stable of all of the protocol layers. So just to close out the philosophy slide, I'd like to touch on a quote, one of my favorite quotes by Dr. Stallman. With software, there are only two possibilities. Either the users control the program, or the program controls the users. And when the program controls the users, it's really the people who control the development agenda for the program who control the users. So that's it for philosophy. The rest of this talk is going to be entirely technical. Getting back to my own personal history here, after I realized that Debian was not going to work for me anymore, I had been extremely comfortable and happy with it, and I had a rude awakening. I was forced to go searching for another distribution. So my initial first choice was Gentoo. Philosophically, I'm extremely well aligned with it. I love the fact that it's all built from source. I build all of my Nix packages entirely from source. I think I'm one of only a handful of people who bother to do that. So I really like the way Gentoo works. I like the community attitude of always compiling from source. I like their strong preference for free software. I'm not super thrilled with Python. It's a great scripting language. I don't know if a scripting language is the right thing to use for orchestrating an entire distribution. I think maybe the world of good scripting languages and the world of good distribution orchestration languages might not really overlap all that much. Guix was my second choice, and I'm going to say a lot more about Guix in about 2 slides, so if this seems a little bit brief, just hang on. It has a strong preference for building from source as well as a strong preference for free software. I like that, but again, the problem's Scheme, and I'm going to come back to that in a few slides. There's people who like Scheme love it, and they're happy with Guix. It's not exactly my favorite programming language. What I really wanted, my dream distribution would have been Gentoo, but take out the Python and put Haskell where it used to be. Of course, that does not exist yet. And Nixos doesn't fit this description. I mean, first of all, it's not Haskell, and it's not even really that close to Gentoo. Nixos, although you can build it from source, almost nobody does. It's really not designed for that. In fact, until very, very recently, in order to build it from source, you had to run this thing called Hydra, which is an incredibly complex piece of software. And almost nobody has the willpower to run a Hydra instance. There's only a few of them out there. But I did realize that Nix packages, which is the vast majority of Nixos, it's what builds the software, and then Nixos is kind of the scripts that bring your system up using that software. I did realize that Nix packages is 95% of what I wanted. So I took the time to learn Nix after realizing that 95% of what I wanted was out there, and decided I was going to build that last 5% myself. If it had not been for being kind of unpleasantly kicked out of being able to use Debian, I would never have learned Nix. If it was not for the fact that Debian removed support for non-systemd users, I never would have discovered Nix, which is an amazing technology, by the way. So I would like to now dedicate this talk to Leonard Pottering. I'm serious about this. I would like to thank Mr. Pottering very much, because if it were not for him, I would never have discovered Nix. So if he's watching, or if he watches the recording, I'd like to thank him very much for this, because Nix is an amazing piece of technology that I would not know about if it had not been for him. So I'd like to say a little bit about the goals and the scope for sixos. It started as a hobby, and I think all really good free software projects do start that way. I think you should be a little bit suspicious of projects that don't start as somebody scratching an itch. It went way, way beyond any reasonable time allocation for a hobby. And in fact, part of the reason I'm giving this talk today is because there are a lot of changes coming up in my life, and I realize I'm not going to be able to devote this kind of ridiculous amount of time and effort to this hobby. So I wanted to give myself kind of a deadline, an end goal to show what I'd learned, to show what the problems were, what the benefits were, and let other people learn from that. Sixos solves my problems today. I run it on my company's large CAD cluster, as well as our GPU farm, and my laptop, and all of our routers, which are MIPS 64 routers. It solves my problems and will continue to do so, but I really can't promise anything beyond that. So if you're looking for a supported distribution, this is not what you're looking for. So let me say a little bit about non-goals. If anybody came to this talk expecting a competitor to Nixos, you're going to be sorely disappointed. That's not what this is. Let me tell you what it is, however. You've probably heard the phrase, build one to throw away. A lot of the best software out there is the result of trying to build what you want, learning all of the lessons about how you did it wrong, throw it away, and start over with those lessons in mind from the very beginning. So my hope here is that Sixos can be the one that got thrown away for someone in the future who tries this again, who tries to do a S6-based non-systemd version of Nixos. I think there are a lot of useful lessons that can be learned, and I'm happy to answer any questions anybody has about that if this is the kind of thing you have in mind. And that's the main thing that I'm releasing Sixos, main reason I'm releasing Sixos and giving this talk today. So I mentioned before that I was going to come back to Guix. I think this is the appropriate time to do that. A lot of people ask me about Guix when I say, yeah, I really like Nixos, but there's this thing and that thing that I don't like about it. They say, well, have you tried Guix? And this slide is another point where I'd like to say I don't think there's a whole lot of people who've really gotten very deeply into both Nix and Guix recently. Obviously, 5, 10 years ago, they shared a lot of infrastructure. They've grown apart significantly. I have not found a lot of people who have a deep understanding of both. I found plenty of people who have a deep understanding of one. And it took me a while to realize I don't think they solve the same problem. So I really do think that trying to compare Nixos to Guix, if somebody asks you, well, which is better, Nixos or Guix, they're kind of asking you which is better, a drill or a hammer. And it depends on, well, do you need to drill holes or do you need to pound nails? You have to know that before you can decide which one is appropriate for you. So Nix solves the following problem. Let's say you have this problem. You want to use side effect-free functions to describe build processes and file system operations. Now, file system operations are inherently side-effecting operations. But you want to describe these using a side-effect-free language, like, say, Haskell. And you don't want to resort to what I will call indirect representations like monads, and I'm not going to explain monads in this talk. So the footnote has been cut off here, but it was completely non-obvious that it's even possible to do this. I would never have guessed that it's possible to do this, and I would say that the biggest insight in Elko Dahlstra's thesis is that he was the first person to suspect that it might be possible to even do this. If this is the problem you have, then Nix is the solution to your problem. Guix, on the other hand, is the solution to a completely different problem. That problem is, I love Scheme so much that I want to minimize the number of hours I spend dealing with any other programming language. The Guix community is amazing. It's a very tight community, very active, but it's people who really, really love Scheme. I wish there was something like Guix with Haskell instead of Scheme. I would be all aboard with that. But if you are not infatuated with Scheme, if you don't think it's the best language in the world, you might not, Guix might not be the right environment for you. So I really do think that Nix and Guix are solutions to different problems. They're not really analogous. They just happen to use a lot of the same techniques in the course of solving different problems. So with all that background given, let me come back to sixos. It consists of 3 layers from the bottom to the top. The lowest layer, which is optional, by the way, you don't have to use it, and you can use it independently of sixos, is Ownerboot, which is a bootloader based on coreboot. And I'm going to say quite a bit more about that later. But if you do use sixos and Ownerboot together, you get a lot of benefits, and I'm going to talk about that as well. The next layer on top of that is infusions, which I will describe as an alternative to the module system in Nixos. So if you're familiar with Nixos, you know that Nix packages does not use modules or uses them only extremely sparingly. Nixos, on the other hand, takes a very different approach. It uses what they call the module system, and I'll be saying more about that. Infuses a much lighter weight, much more minimal, much more restricted way of configuring things. And then finally, I'll talk about sixos, which is an alternative to the stuff in the Nixos subdirectory of Nix packages. So starting with Ownerboot, and I apologize for the small font on this slide. It's been released for quite some time. It's an optional bootloader. Briefly, let me tell you what it does. It uses an immutable pre-kexec kernel, I'll say what pre-kexec means in a second, which is stored on write-protected SPI flash. So almost every machine today, the very first instruction that executes after some sort of mask ROM, of course, is going to come from an SPI flash. And most SPI flash chips have a write-protect pin that you can short to ground. If they don't, you can replace the chip with one that does. So if you're using Ownerboot, the preferred mode of use is that you flash a complete Linux kernel into that SPI flash, and then you short the write-protect pin to ground. So it now becomes immutable. That also contains an initrd. And that kernel and initrd will then authenticate the user, so usually ask them for a password or use some kind of NFC token or otherwise determine that it's the correct user, get credentials from them, and use those credentials to decrypt the writable storage, your NVMe drive, your internal hard drive, or so forth. And authenticated encryption is always in use, so if it decrypts, it hasn't been tampered with. It's not only confidential, it's also authentic. And then the pre-kexec immutable kernel, the one that can never be changed, will kexec into the post-kexec immutable kernel, the one which is updatable so long as you have the encryption keys. Ownerboot is very well integrated with sixos. It has a lot of benefits. All of the boot time loaded firmware is integrated into the bootloader. So you can manage them using the same configuration techniques, same techniques that are used to manage Nixos configurations. So there's actually a profile in Nix var Nix profiles for your boot flash. So you can see, boy, my laptop started acting weird 3 weeks ago. You know, what was the firmware change that I made 3 weeks ago? You'll actually be able to find that in your profiles. So it takes advantage of all of the Nix-based techniques for recording the history of mutable changes, and it applies those to your boot flash, which contains all of your boot time firmware. The most unique feature of all, and the killer feature for me, is that it gives you true full disk encryption, which is not possible at all with master boot record EFI or UEFI systems. You'll notice that the ESP system partition or something analogous to it always has to be unencrypted and therefore subject to tampering. And I'll say one other thing. There have been efforts to solve this problem for UEFI by kind of letting the hardware manufacturers manage our keys for us, essentially by them having the private key for some signing key that can be used to sign a cheat code. I trust my hardware manufacturers to manufacture my hardware, and when they deliver the hardware to me, their job is done. I don't trust them to manage keys for me. That's a very different kind of trust. I don't want to trust them in some kind of ongoing relationship. Once I get the hardware, I'd like the amount of trust I give them to have come to an end. And so the big upshot here is that in this use mode, there is no unencrypted media in the boot process, and all of the encryption is authenticated encryption. So this is kind of the killer feature that if anyone is aware of a system other than Ownerboot that provides this, I'd like to know. I have not been able to find one so far. The downside is that there's a very restricted set of hardware it works on because you have to use core boot, and core boot does not support all of the hardware out there. I'd like to talk next about infusions. This is the second of the 2 layers in the stack. This is kind of the alternative to the Nixos module system. And the key difference, other than being smaller and leaner, is that infusions actually have algebraic laws. And I originally had some slides in here with the commutative diagrams and all that, and I decided that would really bore people. If you want that, it's in the Codeberg repository. It will show you what those algebraic laws are that are satisfied by the infusion operation. I would argue that the fact that it satisfies those laws and is the unique operation which does satisfy those laws makes it sort of the obvious operation to use for merging configurations. Oh no, we have a contrast problem here. Oh my. Nobody can read this, can they? Can we bring the lights down to improve the contrast by any chance? Is there any way to do that? I guess. Are people able to read the, maybe I just can't read it from that angle. No, this one came out way too small. Well, this is unfortunate. You can find the example, you can find these examples in the Codeberg repository if you've got a laptop. It shows you just how much simpler certain things are when you do them with infusions. Yes?
They will find someone who can do it.
Okay. Excellent. I'm going to come back to these slides if they can bring down the lights. So I will come back to infusions later. So I'd like to now point out that Nixos handles services differently than the way that Nix packages handles packages. I'm incredibly impressed with the way Nix packages handles packages. It has these time-tested, extremely refined, extremely powerful tools for manipulating sets of packages. Namely, it organizes packages as scoped fixpoints, the make scope operator you're probably familiar with, and it allows you to modify them and change them using override and override atters. And infusions are just another way of packaging these override mechanisms. I think this is one of the most beautiful things in Nix packages, and it always kind of broke my heart that Nixos did not use this wonderful mechanism that was invented for packages, that it did not carry that over to services. In Nix packages, an instantiated package, so you might have an uninstantiated package would be like GCC, there would be only one GCC. An instantiated package might be, let's say, GCC targeting ARM64, or GCC targeting ARM64 and the compiler appends -03 to every compile job. Or an instantiated package might be Firefox built using particular compile flags. So it's kind of a build with customizations of a given package. Nixos, on the other hand, instantiated services are modules, and although Nix packages inherently supports multiple instantiations of a package, it's incredibly easy to compile Firefox 10 different ways, and in fact have them all on your system at the same time. That does not carry over to Nixos services. There are a few Nixos services that support multiple instantiation, but it has to be done on a service-by-service basis. It's not automatic, it's not inherent, it's not something you get for free. And finally, I point out, in Nix packages, a built package is an out path. It's not clear to me what the analogous entity in Nixos would be. I believe a built package is also a module, so it's not exactly clear how that lines up. Let me now replace the right half of the slide with how sixos works. Just like in Nix packages, an instantiated service is a Nix expression. Or sorry, an uninstantiated service is a Nix expression. So you'll have a Nix expression for OpenSSH, for the OpenSSH server. If you want to run OpenSSH, if you want to run 5 copies of it on different ports, and let's say you want to run it on ports 22, 23, and 10,000, that would be 3 different instances of that service. And an instantiated service is called a target. So just like with packages, an uninstantiated service, the generalized OpenSSH is a Nix expression. And then when you instantiate it 3 times to run on 3 different ports, you have 3 different targets. And each of these targets, each instantiated service is a derivation, just like an instantiated package. So all of the tooling, all of the language, all of the perspective that comes from Nix packages that was so hard won over the last 20 years that Nix packages has been under development, you benefit from that immediately because things are done the same way. And lastly, it's very clear what a built target is in sixos. A built target is an out path, just like a built package in Nix packages is an out path. And in case you're curious, the contents of that out path is an S6RC database. So I've told you what sixos looks like when you're configuring your system. I'd like to now tell you what it looks like when the system is up and running. S6 Linux init, which all of this, the first 3 pieces of software I'm going to talk about are part of S6. S6 Linux init is used as PID1. S6 SVC is the process supervisor. And S6 RC is used for dependency management. So this is essentially similar to systemd's wants lines and also the calculations it performs when you say, I'd like to shut down seatd or my display manager. It knows that it first needs to shut down all of the processes that depend on that. So if I ask to shut down seatd, it should first shut down my compositor first, and then it can shut down seatd. And it uses libudev0 instead of libudev, and because of that, it doesn't need to use udevd. It's kind of surprising, but you can run an entire desktop system this way. And there actually is one over at the CDC. I'll mention that in the very last slide if you want to see it running. You can run a Wayland compositor, browsers, LibreOffice, all of that stuff. A lot of the pressure to move towards systemd has come from the desktop environments who have kind of said over and over, you can't really have a GUI without systemd. I don't know where that comes from, but I think that's objectively not true. And I can show you one if you like. I'd like to mention a few other interesting quirks of sixos. There are no set UID wrappers. They are replaced with 2 solutions to 2 different problems. If you need to execute a privileged command with no inheritance of process state, thank you. In other words, if you have a situation where the privileged process is not a child PID of the caller, which by the way is most of the time that's okay, most of the time that's acceptable, and doesn't inherit any environment variables, doesn't inherit a controlling TTY, then you use S6 pseudod, which is also part of the S6 project. I'm very grateful to S6. It kind of provided all the raw materials that were necessary for sixos. A lot of it was just kind of assembling it into position. So this covers things like unprivileged mount, unprivileged unmount, fuser mount 3, that's the binary for fuse that has to have special privileges. Your screen locker needs to access the etc password file in order to check your password. So because of that, it's usually set UID root, but it doesn't need to inherit any environment variables, and it doesn't need access to your controlling TTY. Currently, sixos does not support users changing their own password or shell because it requires that you manage those non-imperatively. If you wanted to, those 2 also could be implemented using S6 pseudod. If you take away those use cases that are covered by S6 sudo-d, it's essentially a daemon, you connect to it with a Unix socket, tell it what you want to do, it checks the permissions and either does it or rejects it. All of the remaining use cases are covered by a single binary. And sixos uses doas, which is essentially sudo from OpenBSD, but much more minimal, like everything else in OpenBSD. And I have a much easier time trusting it, again, because it's from OpenBSD. This is the only set-UID binary on a Nixos machine. So literally, if you look at the entire machine, it's the only binary on your file system that's going to be U plus S. And it's used to implement SG, which is set group, new UID map, new GID map, ping, and it internally implements SU. So there's really only one set UID binary, and because of that, there are no wrappers. Every configuration is required to have doas. It's a hard dependency, and therefore, it's always going to be set user ID root. I'll just mention one other cute feature. This is one of those things that if you're thinking of creating a Linux distribution, please do this, because it was really helpful. The early user space of sixos, in other words, the initRD, runs inside of Abduco, which you can think of if you've ever used GNU Screen. It's like GNU Screen, but like really, really simple. So GNU Screen has evolved into this very powerful, very large tool. Abduco is like the most minimal subset of that. Basically just, I have these 7 terminals and I want them all to display the same thing. And if anyone types a keystroke into any terminal, they all get sent to the same program. So you have one program displayed on many terminals and receiving input from them. At boot time, both TTY0, which is your video console on your keyboard, as well as your serial console, TTY-S0, if you have one, and I strongly encourage you to have one, those are both multiplexed together with Abduco. What this means is that if your system gets wedged, you don't have to go plug in, you don't have to switch it into boot from serial console mode. And if you've ever been in this situation, you realize that getting the machine to boot from a serial console is not something you can do from the serial console. Usually you have to do that from the video console. So all of the machines in our lab have serial consoles, and it's really nice knowing that I will never accidentally boot in video mode and realize that I need the serial console to do some recovery. So this is always on by default, and as a result, sixos does not have a boot from serial console menu option. It's always enabled. I think this is the easiest to explain, hey, if you try what I did, you should definitely copy this. And that's the URL for Abduco. I'm a big fan of that project. So this brings me to the end of the talk. I guess we didn't get the lighting adjusted, so I did not get to show you the infusion slides. I'd like to point out that there are 2 demos available. This is going to be available tonight. I apologize, I was finishing my slides at the last minute. I'm trying to disentangle my own local configuration from the demo. It will be up tonight, and with 2 commands and a whole lot of compilation, so that's why I'm not too worried about having it available here. It takes about 20 to 25 hours to compile on a laptop. You can boot a demo VM with sixos, and you can play around with it. If you are more impatient, in the CDC Pentagon, which is right over there, you can see those vertical white and red lights. It marks the CDC area. In the center of the CDC area, there's a Pentagon set of tables, and in the middle of the Pentagon, there are 3 monitors. The laptop driving those 3 monitors is my laptop, a copy of it. I have 2 of them. It's my spare laptop running sixos, and you're logged in as a user. You can poke around and play with it if you like. You can even reboot it. So that brings me to the end of the talk. I'd like to say that this has been a long journey for me. I've been working now on Nix packages related stuff for about 3.5 years. I've been working on sixos for about 2 years. And when I realized that I needed to start to get a better hold of how much time I was putting into Nix packages related stuff, I started this process of bringing down my time commitment level. And I think this talk today marks the end of that journey. So I'd like to close with a quote that I really like from the Nixos discourse. I think if you've ever used Nix packages or Nixos, you know it's highly, highly addictive. And it has taken me almost 6 months to kind of get that addiction under control. And it is a dependency that is not easy to replace, but I think it's a dependency that most of us who use it don't want to replace either. So are there any questions?
Thank you very much for this talk. We are open for your questions now.
I know this was a very technical talk.
Yes,
we
have a question.
Yeah,
use the microphone?
Thank you.
Yeah, thank you for your talk. At first, you start with a comparison to other distributions without systemd, but I was missing a short introduction about Devuan.
Ah, yes, I should have mentioned Devuan. It was I was very aware of the Devuan project, which just to repeat the question, the question was that I mentioned several other distributions like Guix and like Gentoo, but I did not mention Devuan. And Devuan was the, I guess you could call it fork of Debian. Is it fair to call it that? That essentially disagreed, as I disagree, with the decision to require only systemd. I was at the time not sure if Devuan was going to succeed. Obviously, it has succeeded since then. At the time that I made these decisions, I was uncertain about whether it was going to Devuan was going to pan out and how difficult their development process was going to be maintaining a fork of Debian in the long term. I guess looking back, I underestimated them dramatically because Devuan clearly has been successful. But on the other hand, just like I'm grateful to Leonard Pottering for making this talk possible, I think maybe it's a good thing that I underestimated Devuan because I would not have discovered Nix if I had stuck with Devuan. So yeah, if anybody else in the audience is a Debian user who wants to use a non-systemd PID1, Devuan is the thing that lets you do that, essentially. So I apologize, I should have mentioned that. We have a question in the back there.
First, I'd like to thank you for the critically important job that you did. This is really, really important. So the question that I have is, so you used Nix packages, Nix
Yes.
OS. I'm not a Nix OS user. I have no information about that. But the question that I have is like how the sixos is really compatible with the stuff that Nix OS, with the Nix OS or Nix packages. Like, can I install anything that Nix have?
Yes, anything that Nix packages has. And if I had a whiteboard here, I would draw a diagram. There's Nixos would be a big circle, and then 95% of that circle would be Nix packages. And sixos is built on top of the same 95%, of Nixos that is called Nix packages. So any software that's in Nix packages will work as well on sixos as it does on Nixos.
So there is no like difficult to manage dependencies on the actual systemd stuff that is embedded in Nix OS or stuff like that.
So if you have like a user desktop program, like say LibreOffice, there's no special support needed from sixos. It inherits the ability to run LibreOffice simply because LibreOffice is in Nix packages. However, if you have a service, a background service, like say some obscure daemon, or a Gopher daemon, let's say. I don't use Gopher. It is necessary to write a small one-line file that expresses, here's the binary you execute to start the Gopher daemon. Here are the other services that need to be up and running before the Gopher daemon. So that does need to be done, but it only needs to be done for software that runs as services. And it's a much easier task than packaging a piece of software.
Okay, got it. Thank you.
I have a quick question. Can it be run just with an upstream Linux kernel? Did you have to make any downstream patches?
I do if you do not use Ownerboot, if you do not use the custom bootloader, you do not need any Linux kernel patches. And in fact, I believe my build farm uses the same kernel build process from Nix packages that Nixos does. I personally run a lot of patch kernels, but it is not required. You don't have to do that. There are a few kconfig options that need to be set in particular ways, but no source code patches.
Another question? We still have time. Yes.
Would it be possible to combine sixos with the binary distribution from Nix packages, so with Hydra builds, for example, that we don't have to spend 25 hours to build our own system?
Probably. I have not looked into that in great detail. I could probably give a whole other separate talk on. I know that Hydra and the binary. The question was whether or not you could use sixos with the Hydra binary cache. In particular, with the hydra.nixos.org binary cache, which is the binaries that are built by the people who have the signing key for hydra.nixos.org. That would be a whole other talk. It's probably possible. Personally, I think it's slightly unhealthy for the ecosystem that we're all depending on this one build farm and this one signing key that has not been rotated in 5 years, that was not generated inside of an HSM. Now, granted, the people who have this key are some of the brightest developers in the world, but everybody makes mistakes. What you're asking for is probably possible. I think it would be healthier to move in the opposite direction, to having more build farms. And I'll say, by the way, this is one area where Guix has really innovated ahead of Nix. I believe they have 2 totally separate build farms with totally separate administration teams and separate signing keys in order to not be reliant on a single one. So what you ask for is probably possible. I don't know if it's something that I would advocate for.
So you've mentioned that A, you don't have time to continue the development of this general distribution, and B, you consider there to be mistakes in your decision making that make it not suitable for such a project?
I wouldn't quite say that. I would say that when you make your first attempt to build something for the first time, you will always make mistakes. And I think that those mistakes you make in the first revision are the most important and valuable thing that come out of the first revision. All the projects I've done that have been big successes, it was always I built one, made a lot of mistakes, threw it away, and the lessons I learned from the one I threw away were the most important thing that went into the one that worked. If there are people who want to carry on sixos in its current form, I'm fine with that. I won't stop them. But I think the most valuable thing that has emerged from this is not so much the code, but the lessons of what worked and what didn't work. The serial console, the infusions, I do hope that the infusions get carried forward. I think that's the part that turned out the best. Some of the dependency management stuff still needs to be worked out a little bit better. S6 does not distinguish between restarting a service versus stopping it and starting it. So if you would want to restart a service and other services depend on it, the services that depend on it have to be shut down so it can be shut down, and then it's restarted and that's restarted. Now, I have patches to S6 that teach it that a restart is not the same as shut down and restart, that you can, shut down and start up, that you can restart a service without affecting its dependencies. Upstream S6 does not acknowledge that this is a possibility, probably for good reasons. There are a lot of corner cases that need to be worked out. So I think that's another one of the important lessons is the S6 world needs to get a better grip on the difference between restart versus shut down and start back up again.
Hello. You mentioned being a Haskell fan.
Yes.
So I could imagine your reaction to like Nix being dynamically typed to be less than fully enthused.
Yes, I would absolutely love to have a replacement for Nix that's statically typed. And in fact, I've several times started trying to build one of those and realized that if I did that, it was gonna turn into another one of these hobbies that just explodes and takes over my life. But sorry to interrupt. Please go ahead.
That was literally my question. Yeah.
that was the question. if you or anybody else is interested in that, I know it's the kind of thing that one person can't do, but I think it would be absolutely fantastic to have something like Nix that swapped out the untyped Nix programming language for Haskell. And in particular, since I have the stage, I'll mention, it's possible to have the best of both worlds. You can have a type in Haskell, the type of Nix values, which is essentially just more weakly typed. And I believe that what I just described has been done for PureScript. So if you know about PureNix, I would love to see something like PureNix done, but instead of using PureScript, use Haskell instead. I think PureNix was kind of an odd choice because PureScript is a strict language. And so you end up using a lazy evaluator to implement a strict language. There's a lot of clash there. But if you had a lazy untyped evaluator like the Nix evaluator, you could evaluate the type erased version of a lazy, strongly typed language like Haskell. So now you see why this is so tempting. You look at it and you're like, wow, I could do this in an afternoon. It's not something you could do in an afternoon, even though it looks like it, but it's definitely doable. So if you're interested in this, by the way, there are a few other people who are casually interested in it, not enough to actually write code. They hang out in the TVL channel on Hackint. Is it Hackint or? Yeah, I think it's on Hackint. One of the IRC networks, tvl.fyi. There are a couple other people in that channel, I'm there as well, who kick around ideas about this. I don't know if any of the others are actually getting around to writing code, but they have interesting thoughts on that. Yes?
Could you show the slide with the infusion, the link with that explains the infusion?
This is the better one, yes. So, by the way, if you've ever used Nix packages and you've wanted to override a Python package, it's a hideous, hideous nightmare because the Python packages are a fixed point within the larger fixed point of the Nix packages package set. So you have to reach down through 2 levels of fixed points in order to do something as simple as this huge pile of code here. All this does is say, hey, this particular package I'm building, don't run the regression tests at the end of the build, because, I don't know, maybe the regression tests don't work on PowerPC or something like that, so you need to disable them. It literally takes I think it's 12 or 13 lines of extremely hard to read code just to do that simple thing. Say, this one Python package here, don't run the regression tests at the end of the build. If you do it using infusions, it's 4 lines, and I think you could probably read the one on the left, but it sort of says exactly what it does. It says, okay, take Python 3.11, which is the set of all Python packages using the Python 3.11 interpreter, go to its inputs, go to the package overrides arguments. This is, by the way, the reason why Python and Nix packages is such a pain to deal with is you have to pass it your overrides instead of simply applying them yourself. Go to the package overrides argument to that uninstantiated package and apply the overlay to the DNS Python subattribute. And the overlay I want to apply to its outputs, the doCheck attribute should be assigned the value of false. So you can kind of read what it does step by step, and even if you don't understand infusions or overlays, you can probably guess what this does. Whereas the stuff on the right-hand side, honestly, if we could read it, I don't think anyone who is not a Nix packages expert would have any idea what it really does.
You talked about a commutative diagram.
Right? Yes.
Where is it? Can I see it?
In the I believe it's in the Codeberg repository, and if it is not, I can put it there.
What's the link of the repository?
It's codeberg.org/amjoseph.
Oh, thank you.
Oh, and not that one. Hold on. No, that one.
Oh, thank you.
Yes. And for sure, the algebraic laws are definitely in the repository, and you can probably reconstruct the diagram. If you want the diagram, I'll draw it for you. Essentially what it says is that there are 3 non-finite types in Nix. There are lists, there are functions, and there are attribute sets. And each of these 3 types has an associative operator. So for functions, it's function composition. For lists, it's list concatenation. And for attribute sets, it's the attribute set update operation. And in all 3 cases, infusion is, how can I put this? What's the best way to put this? It preserves the structure of that associative operator, and it also has a unit. So it preserves the semigroup structure of each of those 3 operations and does so identically at all 3 types. So that's essentially what the commutative diagram says.
So the codeblock repository of sixos itself is empty right
Yes.
now. Is that on purpose or?
Because I finished my slides. If you will give me until this evening, I would really appreciate it. I have currently, the sixos repository is entangled with my own machine's configurations, and I'm trying not to post those online because I'm not allowed to post the list of our internal network map. I know. And it was a choice between finish that or finish the slides. I'm a terrible procrastinator. If you give me 24 hours, I swear it will be up there, and if it's not, I'm AM Joseph on essentially all the IRC networks. You can open obnoxious issue requests on all my repositories harassing me. But I actually do have a copy of the repository where that command works. The problem is there's all sorts of other stuff in that repository that I'm not allowed to release.
Okay, thank you for putting the effort in, and thank you for the
Yes.
talk.
Thanks again.
Another question. Do you have any kind of plans or ideas to upstream the infusions? Because like Sixos itself is obviously a different project than Nixos,
Yes.
but like from what you explained, the infusion seems something like that Nix packages could use, or
Yes.
even Nixos could
If
possibly use.
if Nix packages is interested in putting in the infusion operator into Nix packages lib, I think that would be a great idea. I've made only one change to it in the last 5 months, so it's quite stable. I'd like to see a couple of other users for it, just to make sure that it's stable, because once something goes into Nix packages, we have to provide backwards compatibility. For stuff that's in lib, lib has extremely stringent requirements for backwards compatibility. I would like to see infusions in lib someday. I assume that the maintainers for Nix packages lib would want to see more evidence of stability. Like I said, there have not been changes, but there are not quite enough users to be able to make that judgment. But yeah, I do think that in the long run, it probably belongs in Nix packages lib.
Right. Can you say a few words on how you manage things that aren't just one S6 service definition? Because you can avoid the module system by just composing all of the S6 services. And NixOS itself kind of does this in like the way that it links systemd paths together. But the module system also lets you handle creating random files in /etc or whatever else that you need to do. And I think that's the big value of the module system.
Could you say random files in?
So you can have your service definition that needs to run an actual service, and
Yes.
it also needs to create a file in /etc, and it also needs to do something on boot that shows up in the activation script. And you can compose all of this together into one service definition.
So things that you do on boot are simply other services in S6. There's a main target default, which is the machine has fully booted. So if you want to do something at boot time, you simply add another service for it.
Sorry, rather than
Yes.
at boot time, sometimes there are things you need to do on configuration switch time that cannot involve the service manager because there are various reasons.
I'm a little bit skeptical about that. To be honest, I think a lot of those. Well, what would you give it as an example of something that's not starting or stopping a service?
Composing the PAM files in etc, for example.
Okay, so Sixos does not support PAM. Is there a reason why PAM files?
You need to, depending on what modules are enabled, you have to add lines or remove them from these files, right? And there's not an easy way to have the service manager configuration switch do this itself. So we have an activation script that builds the files from scratch based on the other modules.
The scary Perl script, yes, I've taken a look at that. Honestly, I think one of the goals with Sixos was to not have that big complicated switch to configuration.pl that kind of everyone is terrified of touching. I have tried very hard to not have a script like that.
So I'm just curious if you've run into any things, or for example, like building etc password is another example. Where
etc password, so mutable users is not supported on Sixos. So the Nixos configuration lets you.
Sure. But building the immutable etc password also requires knowing what users everything requires, which. How do you get that if you don't have some structured thing like the module system to keep track of this needs a user as well as a service?
The user is a user as well as a service.
So when you enable an instantiation of Apache, for example, right, you need to create a user as well as actually starting a service. And S6 will not create the user for you. It will only start the service. So where does the user get created?
Well, when you talk about creating a user is just having a line in etc password.
Right, and what creates that line?
etc password is part of the configuration.
Sure, but I mean, the point of the module system is that you can compose all of the things that need to go into etc password in the big fixed point, and then you can put them in etc password. So if you don't have the big fixed point, where do you get the list of things that go in etc
but you
password?
do have the big fixed point. In fact, infusions use fixed points instead of the module merge operation. So there is a big fixed point, just like the packages package set. In fact, I kind of see it as the other way around, that Nixos is lacking a lot of these fixed points. It tries to use the module merge operation instead of using a fixed point where you take prev and you append something to prev. So,
all right, sorry, maybe I was confused by your slide where you said that a service is just a single out path, a single service derivation, but we'll take it offline.
Okay. And if there are any other offline questions, you can usually find me at the CDC. That's where I hang out, so that's a good place to ask questions. Thank you all very much.
Thank you very much.